Engineering Thermodynamics, Unit 5, Psychometry. So, psychometric is a branch of engineering science that deals with the study of moist air, that is called dry air mixed with the water vapor, that is called moist air. So, it also includes the behavior of mixture of dry air and water vapor under the various set of conditions. So, here we discuss about the psychometric properties and the process. So, psychometric properties is dry air, moist air, saturated air, degree of saturation and humidity, absolute humidity and relative humidity, dry bulb temperature, wet bulb temperature, wet bulb depression, dew point temperature. So, these are all the dew point depression. So, these are all the properties of the psychometric, right. So, psychometric properties. So, dry air, the dry air which does not contain any water vapor in suspension, that is called dry air. If the dry air and water vapor mixture is called moist air, and it goes for the saturated state, that is called saturated air, and the degree of saturation is, and the humidity refers the mass of water vapor present in 1 kilogram of air, that is called we represented gram per kilogram of dry air. So, it is called as a specific humidity or humidity ratio, and as well as absolute humidity, relative humidity, psi equal to mv divided by ms, mass of water vapor divided by mass of saturated air, and the dry bulb temperature. So, it is the temperature according air recorded by the thermometer, which is measured by the ordinary thermometer, that is called dry bulb temperature, and the wet bulb temperature is surrounded by a wet cloth exposed to the air, that is called wet bulb temperature. So, these are all the basic properties of the psychometric. So, on basic problems for the psychometric property. So, problem 1. So, a mixture of air and water vapor possesses a volume of 750 meter cube and 1 bar pressure and a temperature 40 degrees Celsius. So, its relative humidity is 70%. So, find the specific humidity, dew point temperature, mass of air and mass of vapor in the mixture. So, given data. So, volume here the volume is given in the problem, volume equal to 750 meter cube, and we take it as a 1 bar as a barometric pressure and 40 degrees Celsius as a dry bulb temperature and 70% as a relative humidity. So, here we find out what we gonna to find out: specific humidity, dew point temperature, mass of air and the mass of water vapor and the mass of vapor in the mixture, right. So, first one is relative humidity. Relative humidity psi equal to PV divided by PS, that is called vapor pressure divided by saturated pressure. So, from steam table here we take it as a corresponding 40 degrees Celsius dry bulb temperature. The saturation pressure is 0.07375 bar. So, that is saturation pressure equal to 0.07375 bar. So, we have to apply the relative humidity is 0.70%, we take it as a 0.7 and PV divided by PS. We have to substitute the value, and the specific humidity is formula omega equal to 0.622 PV divided by PB minus PV. So, the vapor pressure divided by barometric pressure minus vapor pressure. So, the barometric pressure is 1 bar from steam table corresponding to the vapor pressure equal to 0.051625 bar. The saturation temperature is 33 degrees Celsius. So, the dew point temperature is 33 degrees Celsius. So, we take it as a gas law. So, PA VA equal to MA RA into T. So, mass of air equal to PA VA divided by T into RA. So, here we substitute all the values. The mass of air equal to 94.84 into 750 divided by 0.287 into 313, that is called mass of air is 791.82 kilogram, right. And the specific humidity omega equal to mv divided by ma, the specific humidity is 0.0338 equal to mv divided by mass of air equal to 791.82 and the mass of vapor equal to 26.76 kilogram. This is one simple example problem for psychometric properties, right. Next we go for another one problem. Dry bulb temperature and wet bulb temperature of 1 bar air stream are 40 degrees Celsius and 30 degrees Celsius respectively, and determine the humidity ratio, relative humidity and the specific enthalpy. Here the data, dry bulb temperature 40 degrees Celsius and the wet bulb temperature 30 degrees Celsius and the barometric pressure 1 bar is given in the problem. So here we find out the humidity ratio. So before we go that, vapor pressure formula. Vapor pressure equal to PSW. The PSW denotes saturation pressure corresponding to wet bulb temperature minus PB minus PSW into TD minus TW divided by 1527.4 minus 1.3 into TW. This is a vapor pressure formula, where PB is the barometric pressure or atmospheric pressure and TD is the dry bulb temperature and TW is the wet bulb temperature and PSW is the saturation pressure corresponding to wet bulb temperature. So far from steam table corresponding to wet bulb temperature 30 degrees Celsius, the saturation pressure is 0.04242 bar. So here we have to apply all the values in the vapor pressure formula, that is called PV equal to 0.04242 minus 1 minus 0.042442 into 40 minus 30, that is called wet bulb temperature and as well as dry bulb temperature divided by 1527.4 minus 1.3 into TW, wet bulb temperature 30 degrees Celsius. Here the vapor pressure is 0.035986 bar. So first we have to find out the specific humidity. The specific humidity formula is omega equal to 0.622 PV divided by PB minus PV. So 0.622 into the vapor pressure is 0.035986 divided by barometric pressure 1 bar minus vapor pressure. Here the specific humidity is 0.0232 kilogram per kilogram of dry air. And the second one is relative humidity. Relative humidity psi equal to PV divided by PS. From steam table corresponding to dry bulb temperature 40 degrees Celsius, the saturation pressure is 0.07375 bar, that is called psi equal to 0.035986 divided by 0.07375 equal to 0.488, that is called 48.8 percentage. And go for the third one, enthalpy of the mixture. Enthalpy of the mixture H is equal to Cp into Td plus omega into Hg. So we all know that the specific heat capacity is Cp value, Cv value. The Cp value is 1.005 kilojoules per kilogram Kelvin and the Cv value is 0.718 kilojoules per kilogram Kelvin. The Cp, it is nothing but specific heat capacity at constant pressure, and the Cv is nothing but specific heat capacity is at constant volume, that is called Cp value 1.005 and the Cv value is 0.718, both the units are kilojoules per kilogram Kelvin. So from steam table corresponding to 40 degrees Celsius and the specific enthalpy is 2574.4 kilojoules per kilogram. So here the Hg value, 2574.4 kilojoules per kilogram at 40 degrees Celsius dry bulb temperature. So we have to apply the values. H is equal to Cp into Td plus omega into Hg, right. The Cp value is 1.005 into dry bulb temperature 40 degrees Celsius plus omega, that is called specific humidity value 0.0232 into Hg, enthalpy at gaseous state, that is called 40 degrees Celsius dry bulb temperature 2574.4. The enthalpy of the mixture H value is 99.93 kilojoules per kilogram. So this is the simple example problem for psychrometric process, psychrometric properties problem. So we have to studied about the basics, psychrometric properties and as well as psychrometric process. we have to explain in the next video, right? Thank you.